Hi, welcome to the demonstration corner. My name's Kelsey, and today we're going to be talking about the MPV, which is our measurement platform Versatile. So this is our mid-range measurement platform. The basic package includes the TPS method and the transient hot wire method. The transient hot wire method is used for measuring liquids in accordance with ASTM 7896, and the transient plane source method is for testing solids, pastes, and powders in accordance with ISO 2207-2. Included with the transient plane source method is our basic room temperature sample holder. So this can be used for testing bulk materials as well as slab materials for thermophysical properties. And this can be measured at room temperature or up to 300 degrees Celsius with an external oven. So these samples can be measured in the symmetric configuration or in the asymmetric configuration. And this would be by just using a backing of known physical properties. So today we're going to be talking about the optional sensor that can be added onto the MPV, which is our absolute MTPS sensor. So this is a single-sided sensor for testing solids, pastes, and powders. So with this sensor, it can be placed in this carrying case for measuring samples with a top screw to apply the pressure, or with a freestanding weight to place on top. With this sensor, it can also be used in the alternate configuration if you have a larger sample, so you can place your sensor on top of the sample with a freestanding weight and make your measurements that way. So with the purchase of the MTPS sensor, there's 4 modules included. So this would be the bulk module for testing the average thermophysical properties, the slab module for testing materials that are more thin and conductive, the anisotropic module for testing the directional properties of a sample. Here we have our verification sample, which is Torlon. And then we also have the one-dimensional module for testing elongated samples. So today we're going to be looking specifically at the anisotropic TPS module. So we're going to be testing carbon fiber, which is a layered material. So we're just going to set that up with our MTPS sensor in the cradle. So it's a really simple setup. All we're going to do is place our sample on top of the sensor with a protective disc to protect our sample from the screw, and then clamp it in place with the top screw to ensure good contact between the sample and the sensor. So now we're just going to move over to the software and set it up for a measurement. So when we open the software for the first time, we're just going to want to enter some basic sample information. So we're going to enter our user ID and select a location to save our test files. Then we're going to want to select our method. So we're using the modified 3D disk source method with the MTPS sensor. And since we're measuring an anisotropic sample, we're going to check anisotropic. And then that's everything for the general information. We're just going to go next. And here it displays what instrument we're measuring with, which is the MPV. So we'll go next. And here's where we're going to enter some information about our carbon fiber sample. So we're going to enter our sample name. The backing material of the MTPS sensor is already there. We're going to enter our height and radius of the sample, which we already measured previously. We're then just going to select the front port, which the MTPS sensor is connected to, and check the resistance of that sensor. So it gave us a good resistance check, so we're ready to proceed. To select the test time and power for our carbon fiber sample, we're going to be using the proprietary ITPS application, which is the Intelligent Transient Plane Source application. So to begin, we're just going to select the conductivity range for our samples. So if you mouse over these selections, you can just see the conductivity range to select for your sample. So we're going to pick medium for our carbon fiber, and then we're going to hit ITPS to run. So ITPS just runs a continuous measurement recording the temperature rise over time to determine the appropriate test parameters for each sample. So this takes about 2 minutes to finish the entire transient. So while this is running, we're going to move over to our analysis application because we already ran some measurements on carbon fiber. So we're just going to take a look at that while that's running. Yeah. So we're just going to wait a second and just to see this begin before we switch over to the analysis application, and then we're going to let that finish. Yeah, and this is really convenient with minimal user input, so to find the appropriate test parameters for each sample. Okay, so there's beginning to measure just the continuous transient. So now that that's going to run, we're just going to let that continue and move over to our analysis application. So here we already ran the ITPS function and ran a set of measurements. So we ran 5 measurements with the recommended power and test time. This is just the summary of the temperature rise over time. We can move over to the residuals and we can see that there's a random scatter, which is good. So then we can just take a look at our experiment results. So here we can just see the same things that we see for each individual measurement, but it's just calculates the average. So here we see the average thermal conductivity. We entered the volumetric heat capacity, which is required for the anisotropic module. So this was previously measured with our specific heat module. Then we can see our axial and radial thermophysical properties. And at the bottom we see our average and our standard deviation between them. If you wanted to export this to Excel just for further analysis, you can go to these 3 dots in the top right-hand corner and generate a full report and save that. And then it's just automatically going to import these results into an Excel file for further analysis. So here we just see the same thing that we see in the analysis application. So now we can just move back to the acquisition application and take a look at our ITPS results. So here it finished, and we can see the recommended test time as well as power. Once we close that, it's going to automatically dump those parameters here, and then we can proceed to set up a full schedule. So we're just going to add 1 set of measurements with 5 tests and a 10-minute delay. And you can see up here, it just shows those recommended power and test time. You don't have to use those recommendations, so you can input whatever you'd like, but we'll just put the same recommendations, and then you can just hit start, and it'll begin your schedule. And that's everything that there is for making a simple measurement with the MTPS sensor and the Anisotropic TPS module. Thank you for listening. If you have any questions, please don't hesitate to reach out. Thank you.